Welcome to this new session of electromagnetic fields. Today we are going to discuss about the basic parameters which are very important to understand the behavior of electromagnetic fields in space. So let us begin with today's quote. Today's quote we have chosen, which is very interesting. It states that we have to stay away from the negative people. They have a problem for every solution. We have to be part of solution, not the problem. Many times it happens that few students they text to us or in group that the subject we are not able to understand, or the online classes are boring, or we are not understanding anything in online mode. But trust me, they will have same opinion about offline classes also. So we have to keep away from such negative minded students, and we have to keep studying in all the situations and do our best. So I hope we will have very positive energy while studying this subject, and let us begin with today's topic. In previous session we have seen the types of waves. We have seen two types of waves, but we are interested in transverse wave because electromagnetic waves are transverse in nature. So we will concentrate on transverse waves. Transverse waves are perpendicular to the direction of propagation. We have to remember that. And what are these transverse waves? It is a technical name for the light waves. So there may be visible light or there may be invisible light. What is invisible light? Like we have X-rays, infrared or microwaves. These are invisible light waves, and all of them combinedly called as electromagnetic wave. And the spectrum which covers all these different types of wave is our part of study in today's session. Before going to that, let us have the meaning of electromagnetic field, why we are going to study that, and what are the problems are associated with studying electromagnetic field. For that we have to classify the theories. In electronics or electrical engineering or physics, there are two types of theories explained. Either we use field theory or circuit theory. Circuit theory is simple. It is related with only parameters which are coming from voltage and current levels. We know that there are two types of currents. One is alternating current, which is changing with respect to time. This is our time graph. And the current which is constant with respect to time, it is called as direct current. We have direct current, we have alternating current, we have voltages related to those particular circuits. The study of voltage and current comes under the circuit theory. The subjects like electronic devices or digital logics, they deal with the circuit theory. But when we come out of the circuit, when we need to deal wirelessly with the world where wires are not connected, for example our mobile phone has no wires connected with another mobile phone, but still we are able to talk, still we are able to communicate. Our voice reaches to the another person who is not wired with us. So it happens in field theory. There is no direct involvement of voltage and current. But what happens when we supply a voltage source to our mobile phone, like in the form of battery? The battery runs the mobile phone, and when we transmit some signal, either it is text message or a call, then the mobile phone must transfer it into the field where voltage and current values must be converted into field parameters. So directly we are not going to deal with voltage and currents when our signal is out of mobile phone, or when it is in space, when it is traveling across a particular situation or medium. In that case, we are concerned with the field theory. The subjects related with field theory includes electromagnetic fields, microwave engineering, radar systems, even some part of satellite communication. Wherever there is involvement of any part of electromagnetic spectrum, we have to understand the field theory. If you are a mobile phone user, if you are a user of various gadgets, wherever there are various kind of waves are involved, then this subject, these concepts are for you. So this is about the field theory. We are concerned about field theory in this particular subject, we have to remember. Then next we will discuss about the meaning of electromagnetic field. Before that, we will break the electromagnetic term. Electromagnetic term, first part consists of is electrostatic. When we talk about electrostatic, what does that mean? Electro means related to electric field, and static means which is not moving, which is in rest. That means our system is not in motion. And second part of electromagnetic comes from magneto. It is magnetic field, magnetostatic. Magneto means it is related with magnetic field which is not moving. So when we study electrostatic separately, magnetostatic separately, the combined knowledge will give us the clear concept of electromagnetic. So to understand electromagnetic, we will first study the case where things are static, not moving. Once we understand the situation where static charges or particles are considered and we analyze them, we understand them, then we can easily turn to the moving objects. So we can move to the time domain. So by studying electrostatic and magnetostatic, we will understand electromagnetic waves. So electromagnetic, next part is field. What is field? The simple meaning of field is any place where number of forces are working together. For example, if you like to play football or cricket, so you can say that I am going to field. That means you are going to the playground where number of forces are working together for a particular task. For example, you may need to win the match. Then you are applying your force to win that particular match. Number of forces are working together for one particular task. In classroom, teacher tries to explain his concept to the students. He's applying some force to share his knowledge, and students listening the class, they are applying their force to understand the knowledge. That is the field of knowledge, we can say. So in this case, when we talk about electromagnetic, that means there are electric field and magnetic field components and they are working together for one particular task. So electric field means the place where electric forces are working, and when there are number of forces working together, it will have a particular intensity. There are 4 fantastic alphabets which are related with this subject. When we say field theory is nothing but the field parameters. A field which is a 3-dimensional place. So what we have to remember about the waves? First thing, they are in fields. They work in a space. They are having a number of forces working together. Which forces? These 4 alphabets. Everyone must remember it forever. First is electric field intensity. That is given by capital E. The bar on or the cap on the head of E demonstrate that it is a vector. So they are vectors also. And where these vectors are working? These vectors are working in space, a space around us, a 3-dimensional place. So one parameter, capital E, is called as electric field intensity. Wherever there is intensity, there will be density. So electric flux density associated with electric field is given by capital D. As they are vectors, we are showing bar on the head of these alphabets. These 2 parameters, E and D, are associated with electric field. Similarly, there are magnetic field components. Magnetic field intensity, it is given by capital H, and its density is given by magnetic flux. Let's make it simple. All of us know that light is an electromagnetic wave. Visible light, it's all around us. Now when you talk about light, it is present around us. Is the intensity of light same at all the places and all the times? No, it is not same. If you are in a room, there may be more light around the window. There may be more light near to the light source, bulbs or the tube lights. But in the corners, under table, where there is no reach of that particular light, there will be less intensity. Wherever there is intensity, there will be a density associated with that. Intensity and density are directly proportional to each other. For every parameter, we will have intensity and density. We are concerned with E and D for electrical. We are concerned with H and B for magnetic field. These intensities are also called as strengths. So capital E can be referred as electric field strength. H can be referred as magnetic field strength. Capital D can be termed as the density. These are two densities. So these are electric flux densities and magnetic flux densities. So in today's comment, you have to write these 4 parameters in the comment, which are the 4 parameters of field theory. That will be your first question. All of you must answer it in the comments. Now we will move to the parameters. One by one we will discuss these parameters. So we have discussed about field. So if we take an example, why we refer the example of mobile phone? Because usually we use mobile phones. So in all the communications, there will be one transmitter and one receiver. Someone is sending information and someone is receiving the information. So here we have one transmitter, one receiver. So the field is the place which is connected between the transmitter and receiver. This place, there is movement of electric and magnetic fields. This space, there is application of number of forces. Which forces? The electric field and magnetic field combinedly. So this is something defined as the field. We have to remember field, that our 4 parameters. E is electric field intensity, H is magnetic field intensity or strength. These are the parameters of field. Second, all of them are vectors. So what are the vectors? Vectors, all of we know that vectors have both magnitude and direction. That means E, when we say there is E present in the space, that means it is a vector. It has direction and magnitude both. It will have a value. So we should be knowing the basic operations of vector. So these are the prerequisites of the subject. What is meaning of prerequisite? Prerequisite means what is the basic knowledge we require from the previous classes to understand the concept of present subject. For example, we are studying electromagnetic fields now. So but we require some previous knowledge to understand the concepts of electromagnetic field clearly. So we know that they are vectors. So we must be aware of the properties of vectors. That we will discuss in the next coming class. What are the vector parameters which we require to understand the electromagnetic fields? So there are various properties. There may be vectors, combinations and subtractions in the space. So what happens if the 2 vectors are perpendicular, right? So second thing is that they are all operating in space. Suppose E is there, electric field intensity. It is a vector, and where it is working in space, 3 dimensions. So what is our second prerequisite requirement? That we must know the knowledge of coordinate systems. So what are coordinate? Which coordinate system we require? We may require cylindrical coordinate system, the Cartesian coordinate system, or the spherical coordinate system. The knowledge of these systems is essential to understand the concepts of electromagnetic field, because our field parameters are operating in space, a 3D space, and that's what we call imagination. We require a lot of imagination to understand this subject easily. So this concept we have to understand. So various parameters of vector analysis, how vectors operate in space, and what are the different coordinate system we will discuss in the next session. So what is in general the electromagnetic theory? Electromagnetic theory is a discipline of physics and engineering where we have to study the charges at rest and motion. So suppose this is the source, this may be the antenna, and it may be applying some force, and this particular ball is representing a single small charge. So first we'll understand the effect on a static charge that is not moving. It will come under electrostatic. So we'll study the principle of electromagnetic on a static charge, and then we will also study the effect on the moving object. Like, what is the moving charge? If our mobile phone is moving from one place to another place, and if we are able to communicate with antenna, that means the particles of electromagnetic wave are in motion. So we have to study the charges at rest and in motion. That is part of our electromagnetic theory. So now let us move to the animation, and we will see what are other parameters required and what are the what other invisible lights we are talking about involved in the spectrum. Our eyes see only visible light, the rainbow light, the waves which are found in the middle of the spectrum. With bare eyes, we can't see the other wavelengths on the spectrum. Those are termed as invisible light. But some animals and technologies can read those frequencies. For example, bees see ultraviolet light waves coming from the sun. And flowers have ultraviolet marking. Those are called as the pollen guides. Bees see a bullseye for nectar, but we can see just pretty pattern on the flower. It's all about light from heat for the mosquitoes. Mosquitoes can see in infrared, and they can very easily detect the warm blood. Radio waves have the longest waves on the spectrum. We are going to see about the spectrum shortly after this discussion. But those are so lengthy, sometimes one wave starts in one country and it completes one cycle in another country. Like that, there are many other applications. We require a proper gadget to access the invisible lights, what we are calling. Once you are in a classroom, there are so many different type of signals around us. There may be FM radio signals. If someone play FM radio, he can listen the songs. There may be news channels. There may be so many different internet stuff. There are so many signals around us. But can we hear them? Can we see pictures moving in the air? No, we cannot. There are thousands and thousands of the things moving in the space around us, across us. Someone is calling in the classroom and those signals may be passing across us. But we cannot detect signals like this. We require a proper gadget to access that particular frequency or that particular wavelength. If we have microwave, then only we can use it for the cooking, heating the food. We cannot access microwaves without any proper gadget. We require X-ray machine to see inside the human being. Each electromagnetic wave have two components. One is related to electric field and another one is related to magnetic field. Every electromagnetic field have a specific frequency. Let us discuss what is frequency and wavelength. These waves are sinusoidal wave. We can consider horizontal wave as electric field intensity and vertical wave as magnetic field intensity, or we can consider horizontal wave as magnetic field intensity and vertical wave as electric field intensity. It depends on the polarization that we will discuss in some other class. Now, every wave have its peak value. It's a alternating signal, continuously changing values with respect to time. Signal is passing in time from one place to another place. These two movements can be considered as ocean wave and the snake wave. The vertical waves which are moving up and down can be referred as ocean wave. And what is another wave? Another wave is moving on the ground on the surface like a snake on the horizontal plane. These two waves of electric and magnetic forms electromagnetic wave. From every angle it appears differently. Like we can see here in the front view, we can see only a plus sign. But in 3D shape, these are the two waves. From side view, we can see only vertical wave, say electric field intensity. From top view, we cannot see electric field intensity component. We can see only magnetic field intensity component. But when we see it from a particular proper angle, we can see that it is an 3D electromagnetic wave with two moments. In next session, we will cover the examples on frequency spectrum and other parameters of electromagnetic field, including the transmission lines. Till then, have a good day. There are two questions hidden in the video. You are supposed to give answers in the comment.